Alright, I'm going to make a rather short video here about adding more than one vector together at a time, and sort of just the systematic way to do it. So we discussed earlier how really all these vectors can be combined. We're working in two-dimensional space, means that all vectors can be combined to just two vectors. I mean, that really is what can happen. I can give you a list of 400 vectors, and it might take you a while, but you could combine them into just two. And so that's our goal here. And we're going to combine this into either a north-south or an east-west. I just like to put a little reminder: east is positive, west is negative, north is positive, south is negative. Now the real secret here is we actually are pretending there are only one direction this way. There is only north. And instead of saying south, we're actually saying negative north. If that makes sense to you, good. If not, don't really worry about it. You just use the positive and negatives here. But I said the positive and negatives weren't useful unless we're going to be combining, and that's what we're doing here. So I'm going to start by writing down every vector, including whether it's positive or negative. So first one says 5 meters north. So we have 5. Oh, I should take a moment here and say the reason why we're combining them is because we can only add two vectors at a time. You have to use Pythagorean theorem, and so you have to have two orthogonal vectors. They're kind of considered to be unit vectors, is really what you need here. So we're going to combine everything into just two vectors. So we have 5 north, so that's positive 5, good. 3 south is going to be negative 3. 2 east, okay, that's positive 2. 4 west, negative 4, and then 3 north says positive 3. So we can combine all these vectors together. Starting with the north-south, we get these 3 and negative 3 cancel each other out, because we're adding them, by the way. We're adding all these vectors together. So these got to cancel. You just end up with 5, positive 5. Over here, on this side, you get 2, and negative 4 is just negative 2. So again, what we have here afterwards, we now know what our net north-south is and our net east-west is. Our net north-south is positive 5. So we have over here, if this will load, there we go. We have, really this turns into, so this entire problem really has now boiled down to, it has become 5 meters north, because this was positive. And this negative is really negative 2 meters east, but we'll probably rather say 2 meters west. And if that problem just said that, this is an easy problem, right? You can just use Pythagorean theorem now. So basically you can sort of systematically boil everything down and then just use the Pythagorean theorem. So we know that the resultant, C, is going to be equal to the square root of 2 squared plus 5 squared, which is the square root of 4 plus 25, or in other words, the square root of 29, which I don't know what that is right now because I don't have my calculator with me. I was ill-prepared, but you can just punch it in the calculator, or you can leave it square root of 29. There's no perfect squares that go into 29, so that would be a valid option. Of course, this is meters, and our direction is northwest. They're about to hear an announcement. Oh, there you go. Of course, filming at 4:08 and still get announcements. Anyways, this is the correct answer. I think that's really all I want to show you on this. So again, if there are more vectors, you just add them, continue to combine them. And again, I like to do the 2 columns just because it makes it really nice and organized. But I think that's it.